Welcome to session number 6. We are going to continue talking about the shortcut icons. We've discussed most of the icons up here. Let's move down to this row. These are the annotation icons, shortcuts. So if we select that, we can put a label there, add it. We're not seeing the icons. The reason for that is I told it to hide the icons. So let's go to display options and show all the annotations. So we weren't showing the annotations. Here they are now, survey and annotation 2. If we want to move any of the annotations, a little box appears. And if we want to actually edit what's in there, we select the pencil mode. Select number 1, survey, or number 2, annotation number 2. And then we close those. So if you want to get rid, this is an active state, so we have to turn that off. All right, so now these are fixed in place. What are you? We demonstrated before. You can open it up, change the sample description, put a special description just for the spectrum. Display options, we saw that before, very valuable. Helps us to choose what features we're going to show, what colors we're going to show, whether we're going to use a solid line or a dashed line. Are we going to fill some of the peaks with a hash, a brush, or a solid brush for the peak fits? Let's move over. We can modify the actual scale that's here. For example, 900, and we hit accept. Now here at the far left, it has been expanded to just show 900. If you want to reset it, you simply hit reset here. If we were wanting to differentiate this data, let's go to high-res data. We can select differentiate. This is mainly meant to be used for OJ, but it's useful for a demonstration just now. I've undone that. Now I can also smooth all the data. It's an important function sometimes. Moving average is very common and very easy. So you smooth it, produces a very nice result, which you can go ahead and peak fit. Here, this is to remove non-mono satellites. If you're working with an older X-ray source, you have to go find the that file, which is hiding in your directory. It should be on your C drive. And you open this. And you go down and find the non-mono text. You open it, and then you tell it to remove X-ray satellites. You select aluminum. You don't see the effect here. You'll see it on survey spectra. Now we have the option here to do a variety of y-axis modifications. If you want to do some particular scaling to get it a particular size, or if you've got two different data sets collected with different conditions, you can do multiplying to get the good alignment, or you can do division. You can just add counts to offset the baseline a little bit, or you can do a simple flat background subtraction. This is meant to be used for charge shift correction. It can be used for other things, just to help overlay two spectra and do a shift in the x-axis. If we were to accept this, then this peak right here would shift by, let's see, right now it's 99.7. So if we select compensate, it will move by that much. And so it's now it's at 104.2. Then if you don't like that, you can simply undo it and go back to the original value, 99.7. We don't have any depth profile data up right now. We can't show that to you. We can subtract, right now we've got 200 counts here. If we hit this, then it goes through. It was already at a minimum, but now all of the spectra are at a minimum, down very close to 0, so that we can overlay the spectra much more readily. Let's show you what a linear background looks like. I'm going to zoom in here, and we're going to do a define baseline. So if you try to define the baseline first by selecting that, it tells you you've made a mistake. So what you really need to do is start here with the mouse cursor, draw a box, and then choose the linear baseline. Or you could choose a Shirley type baseline. You can see the difference between those two. The Shirley type is with red dots, and the linear is black solid line. There's one more option available, a full Shirley. It will extend the existing Shirley all the way out to the end. Sometimes this is valuable for subtracting baselines or for fitting data. Two-guard is best used on survey spectra. We won't demonstrate it at this time. I'm going to go ahead and demonstrate briefly the peak fitting, and that will be the end of this session. I have to undo what I have done, removing everything. All right, now we're back to raw data. So now I want to do a quick demonstration of peak fitting. So we need to make a baseline first. Always you have to make a baseline first. I'll choose Shirley. If I press here, it changes the red dots to a solid line. That means it's accepted that. Now we want to add peaks. So we start here. We draw a zoom box. One way to make a peak. At the full width half max position. Don't come up here and don't go all the way down here. Go about a halfway up the peak. Okay? And then select that. It adds a peak. Okay? Now we want to add another peak. It has, as we chose it, we told it to do automatically jump so much, 1.5. So we're going to move it and adjust it. Add that peak. And let me move this out of the way. There's actually an SI20 peak there. I want to add that peak. And it jumped again. And over here, there's actually SI203. If you get into the more advanced aspects, add that peak. And then the final peak. That's the SI02 peak. All right, now we've got all the peaks added. We simply tell it to iterate the peaks. That's start peak fit. And within a short time, it has optimized. The reduced chi-squared is 1.6, which is quite good. But then you got to go in and check all the full width half maxima, make sure they all make sense. If you want to check and put in constraints, you open up the peak fit table and constraints. And there's a world of control that you can exercise. So I'm not going to show you that right now. If I select any of the lines, then everything pops up. Here we can control how fast the peak fitting goes, but we'll show you that later. That's pretty much it for the main icons, and we'll stop this lesson here. Thank you.